Good evening, everyone. I welcome you all to today's Focus Weekly session dated 10th March 2025. The topics which we are going to discuss are displayed on the screen. And today, as we all know, that is the day for the Geography and Environment session. All the important news articles which have been covered by the important newspapers as well as magazines in the last 1 week. The topics range from the climatology, that is La Nina in the Equatorial Pacific. Then we'll come towards the topic related to environment, disaster management, and geomorphology, the intersection, and we'll understand that what is so unique about the Himalayas and why there are so many instances not only of avalanche. The topic is in relation to avalanche, but we will discuss by far the large the disturbances or the other important weather extremities or geophysical phenomena which are taking place in Himalayas, which is making Himalayas one of the most vulnerable sections. Okay, so because this can be an independent question in the mains, so that is why we'll be discussing this also. Then from the prelims perspective, we will be discussing the Wallace line concept and what is Wallace line, what do we mean by it, why this line is so important, how it has impacted biodiversity. We'll discuss the important key facts related to the Madhav National Park because recently it has been named as the Tiger Reserve in Madhya Pradesh. So we'll discuss those facts also. Then the next topic is the Gangetic dolphin, the national aquatic animal. And again, because we know that wildlife species are very important, this species is endangered in the IUCN list. So obviously we have to discuss this, right? And then we will be discussing the climate damage fund also because of the recent development which has taken place because of the US exiting out of this climate damage fund. So we shall be discussing these things. And these are the 6 topics from prelims as well as mains perspective, right? So without wasting much time, let us begin with the first topic. The first topic which we are going to discuss is the Himalayan tragedy. The immediate context in which this news article has appeared is because of the recent avalanches in the Himalayan states. Okay, so the topic in newspaper, there's an editorial in the Hindu newspaper which has talked about the avalanches in the Himalayan states. But when it comes to mains, so we have seen that in General Studies paper 3 as well as General Studies paper 1. So this topic can be asked in both the sections. So in both of these papers, when we see the geography, we take the geography and environment section into account, we will see that how UPSC every year is asking the questions which is demanding a regional analysis of a particular region. For example, you must be knowing the questions related to the resource potential of Deccan Traps. So this is an example of what that you analyze a region. A region is Deccan Traps in terms of resources. Similar question was asked the next year, resource potential of the long coastline. So here, the India's coastal areas, it is region. You have to analyze that region in the context of what resources. The question have been asked that how landslides differ in Himalayas and Western Ghats. Again, you have to analyze Himalayas and Western Ghats in terms of landslides, right? So basically, that UPSC is not asking a question that what are the factors responsible for landslides. It is asking you that how much are you aware about all those factors which are operating dominantly in different regions of India, right? So that is why, yes, we know that in totality, India is very much vulnerable to various types of disasters. Okay, so if we have to map a disaster profile, we know that there are landslides also, there are tsunamis also, there is coastal erosion also, there is earthquake, then there is cyclones, there is cloud bursts, glacial lake outbursts, flood, droughts, floods, etc. There are a lot of disasters. So here we are not going to map the disaster profile of overall India. We will analyze the Himalayan regions, that what is the disaster profile of Himalayas, what are the environmental issues which Himalayas facing, and what are the factors which make Himalayan regions as one of the most vulnerable regions when it comes to the environment associated disasters, right? So let us start this discussion. So if we draw a small map, until then obviously try to brainstorm your points, that if I ask you which factors make Himalayas more vulnerable to disasters, so try to think about those points. Okay, so let us say that if this is the rough map of India, right, and this is basically the Himalayan section. So if I have to, let's say, draw this thing, so here we have the Himalayan ranges spanning across all the major Himalayan states, areas of Ladakh, Jammu Kashmir, Himachal, Uttarakhand, Sikkim, Arunachal. Okay, so this is a Himalayan section for which we are going to discuss. Think about the important disasters which are operating in Himalayas. So, for example, this newspaper has come up with the topic of avalanche. So, let us start with this. Okay. So, let's give first heading that one of the most important disasters in the Himalayas are the mass movements, right? So, if we are talking about the mass movements in general, what are the factors? What are first basically the mass movements? Mass movements is the downward movement of large mass of earth under the sole influence of gravitational force. Okay. So, for example, if here we are talking about avalanches, which is one example of mass movement, another example of mass movement is landslides, right? Another example of mass movement is solifluction. Okay. Here we will be primarily dealing with avalanche as well as landslides. Avalanches and landslides, we know that are the movement of the earth debris down the slope of the Himalayas or the mountains, and they move down the slope. Why? Because the gravity is acting on them. So let's say if this is the slope, so this earth particle is this earth sediments are basically moving down because here you are having what you are having gravity, right? But along with gravity, there are few factors which can intensify or which can aid the mass movements. Okay, so what are those factors we have to think? So, what are the reasons responsible for making Himalayas more vulnerable to these types of mass movements? The first reason is that Himalayas are geologically or tectonically active, right? So if there is intense tectonic activity going on, because of this tectonic activity, obviously there will be disturbances in the rock. If there is disturbances in the rocks, there can be some earthquakes which can basically destabilize the established geological system. If there is destabilization, if there is mechanical instability, so obviously we can understand that there will be larger amount of sediments which will move down and will further can intensify avalanches and the landslides. One is tectonic activity. Second is the sedimentary nature of the Himalayas. Okay. So if we are talking about sedimentary rocks, which we know are basically the soft rocks, these sedimentary rocks, because are the soft rocks, so the cohesive strength between among the particles of the rocks is less. So whenever there is any external force which is applied on those rocks, for example, if the gravity is applied on the rocks, which is having a less cohesive strength, so obviously that rock will be more vulnerable to fractures, more cracks will develop, and eventually it will lead to the breaking of that rocks and breaking and the downward movement. This breaking and the downward movement is what is basically the mass movement. So one is tectonic activity, second is sedimentary rocks because you are having soft rocks. Then can we also talk about the steep slopes of Himalayas, right? So because the gravity is directly proportional to the slope gradient, if the slope gradient is high, then obviously gravity action will be higher, then obviously the mass movements will intensify. And because Himalayas are known to have very steep slopes, so this is also one of the reasons for this. Can we also think about intense rainfall, especially in the Arunachal Himalayas, right? So this is also one of the factors which can lead to the mass movements. Okay. And then obviously along with all these factors, we can obviously write about all the human factors, which will be common to almost every type of disasters. For example, tourism is going, infrastructure load is going, human presence is going, urban settlements are growing, the wetlands have been encroached in Himalayas also, deforestation is taking place. The point is that because we know all the human factors, so that is why here first we are dealing with the natural conditions which are there in Himalayas, right? And not just this mass movement, that avalanche or landslides. Himalayas are also equally vulnerable to earthquakes, right? So if we are talking about the earthquakes in Himalayas, these earthquakes are also very important disasters. We know that a lot of Himalayan regions are falling in zone 4 and zone 5 of the earthquake hazard map of India. Recently, there have been the epicenters which have been located in Afghanistan, in Pakistan, in Hindu Kush ranges. And some of the recent earthquakes have found their epicenter in Delhi also. So that will be a different concept. But here we know that this Hindu Kush range, the Himalayas in the Nepals, and this portion of Arunachal, they are very much vulnerable to earthquakes. Again, how that why Himalayas become so vulnerable to earthquakes? Almost similar factors. Yes, there is a tectonic collision going on, right? This tectonic collision is very important because when we talk about the Himalayas, here also we are having two convergent plates forming a one convergent boundary. But these two tectonic plates are of continent-continent nature. So there is CC convergence which is going on. CC convergence is important because when there is an absence of oceanic plate, okay, we know that oceanic plates are denser, continental plates are lighter, they have less density, they have rarer. So if there is some oceanic plate involved in a type of convergence, because of its higher density, the oceanic plate will try to subduct, right? And if it is undergoing subduction, that is, it is moving deeper into the earth, that means the focus of the earthquake might be deeper. So that means where you are having the oceanic plate, there you might have deep foci earthquake because the plate is subducting, plate is going deeper. Here you are having CC convergence. If there is a CC convergence, so what is happening is that there is no active subduction involved. So let's say these are the two tectonic plates. There is no subduction involved. There is just a double layering because both the plates are of similar density. There is no heavier or denser plate not going down. So it will not go down, and that is why here when you will be having the earthquake, they will be relatively having shallow foci, right? So because they will be shallow foci and hence their impact also can be larger. That is why you have high intensity earthquakes in the Himalayan regions. So this is tectonic collision in with respect to the convergent nature of this particular area. This is Indo-Sangpo Sachar zone, right? You must have heard about or read about it in your textbooks also. This is one thing. Second, obviously the same factor, sedimentary rocks, that is the soft rocks. So if the rock systems are softer in nature, then obviously whenever there is a mechanical shaking, so obviously a vulnerability risk will be higher, right? Because there is a mechanical shaking and the rocks are soft, they are having less cohesive strength. Again, the earthquake impact can be high, right? Are you getting it? So similarly, can we think about other disasters? So yes, we can think about the cloudburst, right? So what do we understand by cloudburst? What is this phenomena? Cloudburst basically is a phenomena associated with very intense rainfall over a very smaller localized area. So if we have to define cloudburst, it is localized intense rainfall. Okay. And that is why if the localized intense rainfall has to take place, what does it require? One, either it requires a very high intensity convection, or it requires a very fast and rapid upliftment of the air when it strikes the mountains, which we call the orographic upliftment. So because we are talking about the Himalayas, there obviously we cannot expect convection. Hence, here you get the orographic rainfall. So let's say if this is a mountain range, when the wind strikes the mountain, and if the orientation of the mountain is such that it is lying perpendicular to the direction of the wind, then what will happen? This wind will be forced to be uplifted along this mountain slope. If this slope is steeper enough, steep gradient, which we know that Himalayas have very steep slopes. If this gradient is very steep, then the rate of rise of this wind will be very fast. If the wind is rising very fast, that means what? That we all are aware about the concepts of environmental lapse rate and adiabatic lapse rates, that when we move up, the temperature goes down, right? So when this air will rise up fast, its temperature will go down rapidly. When its temperature is going down rapidly, then what will happen? There will be faster formation of cumulonimbus clouds near to the Earth's surface level. Okay, because now the air has not got enough time to rise to larger extent and then form clouds. Because it was a very rapid upliftment, so the cloud formation has taken place at just small elevation, small height. Here you get cumulonimbus clouds. These clouds are known to have very intense rainfall, and because clouds are formed almost near to the Earth's surface levels also, so that means their impact is going to be very high. So that is why you will get very high amount of rainfall on the windward side of the mountains. Why? Because when this is rising, the condensation rate is very fast. And if the condensation rate is very fast, then obviously cloud formation is very fast, and then obviously the rainfall is very intense. So this is a cloud burst, right? And in Himalayas, we know because there are steep gradients, so obviously it becomes, for example, in this particular section, that is the northeastern hills. Okay, so this section of Himalayas has what? This section of Himalayas is vulnerable to the cloud burst. Similarly, the Uttarakhand region and the Himachal Pradesh, these two states are also vulnerable to the phenomena of cloud burst because of the natural reasons, right? Think about any other disaster. So we can talk about the glacial lake outburst floods, GLOFs, right? So what are GLOFs? These are glacial lake outburst floods. What do we understand by this? So when the glaciers move, they bring some sediments with them. For example, when the river moves, we know that they bring a lot of sediments which are then deposited and are known as the alluvial deposits. Similarly, when the glaciers are moving, they also bring a lot of sedimentary deposits with them, and these glacial deposits are known as what? They are known as moraines, right? It might happen that these deposits which are brought down by the glaciers might be deposited in some area which will not allow the glacier to move further. Let's assume that these deposits have made a temporary wall and it blocked basically the path of the glacier. And during summers or because of the climate change, the glacier also melts, the glacier recedes. When the glacier will melt, then in this particular section, you will be left with what? Glacial melt water, right? So because there will be accumulation of the water, which is melted, which is a melted part of the glacier and is collected because of the deposits which were brought down by the glaciers. So can I say that a temporary water body is formed which is known as a lake? So temporary water body, that is a lake, is formed because of the glacier, and hence it is known as glacial lakes. When, because of n number of factors, let's say very high rainfall, let's say earthquakes, let's say the sudden increase in the volume of this glacial water, because of any reason, we can imagine that there can be a situation whereby these moraine walls, these sedimentary walls can be breached and all that water can flow down, right? So you can draw a similar analogy from the dam's reservoirs. So basically when you build a dam, it basically does what? It basically blocks the river. Okay, if it is blocking the river flow, that means in the back end area you are having a reservoir. Okay, so this is a glacial lake over here, and this dam wall, which in dams you make it artificially of concrete, but here this wall is made up of glacial deposits. Now imagine if this dam wall breaks, then obviously all the water in the reservoir will flow downstream. Similarly, if these moraine deposits, these moraine walls are broken, then also the water will flow down. So same functioning is there in the dams also, and it is there in this GLOF phenomena also. And then obviously because sudden release of water will be there, and this sudden release of water will lead to the flooding in the downstream areas, right? So this is also one of the reasons. Then Himalayas obviously are known to have or known to experience floods. Okay, now this is a very unique thing. Generally, we know that floods are the characteristics when the rivers flow laterally, when they expand their lateral area, which is because of the meandering. And that meandering, we all know, is a chief characteristic of a river in mature and old stages. That is why you get most of the floods in the eastern UP section, in Bihar section, in West Bengal section, because it is a plain area. The rivers have reached their maturity or the old phases. That's why there is a later expansion and hence you experience the floods. What is making Himalayan rivers in Himalayas, that is during the youth stages, you are having floods? So it is a very unique characteristic that rivers in the youth stages in Himalayas are experiencing floods. Why does this happen? So again, there are chief characteristics for it. One, just think about the general factors that why will there be a flood? There will be a flood in any area when there will be a deposits of sediments. Those deposits of sediments will impact the river to move laterally, okay? Or those deposits of sediments can reduce the channel capacity. The channel will become shallower, and that is why now the channel will not be able to control the amount of water which earlier it was controlling. So because the depth of channel has reduced because of the continuous sedimentation of the channel bed, river bed, okay, so now it cannot hold that much amount of volume. So that is why whenever the volume will increase of the water, that river, that water will outflow, will lead to flood. That means you need deposits basically. If there has to be a flood, there will be sedimentation, there will be deposition of the deposits which can lead to floods. So in Himalayas, you just need to focus on those factors which is increasing the sediment load of rivers. In Himalayas, we know that the rivers are having a very long length. So if the rivers are having longer courses, that means the erosion which those rivers are making, that erosion will be higher. If erosion is higher, that means the sediments will be higher. That means deposition will also be higher. So rivers are having longer length. Okay. In Himalayas, you typically find, for example, let's say these are the Himalayan ranges, parallel ranges. You will typically find that the rivers basically move like this between the Himalayan valleys. Okay. So now, because these rivers are taking this path, which is increasing the course, the length of the river. So this reason explains this. Second thing is, the Himalayan rivers are antecedent also, right? So if the Himalayan rivers are antecedent river, that is which originated before the evolution, before the formation of Himalayas, these antecedent rivers are also known to have high erosive intensity, hence higher erosion, higher sediments, higher deposition. Okay. Then again, soft rocks of Himalayas. So if the rocks of the Himalayas are softer, that means again more vulnerable to breaking, more vulnerable to weathering, erosion subsequently, and then leading to the floods. Are you getting it? So these are the important disasters which are there. Yes, one more disaster which we can think of is the wildfires. Okay, so these wildfires are also very important, especially in which areas? In the northeastern states as well as Himachal and Uttarakhand. In northeastern states, we can say that wildfires are mainly because of the jhum cultivation, that is slash and burn agriculture. In Himalayas and Uttarakhand section, we call it that whenever there is a dry season, so when the winds are very dry, they become vulnerable to the wild forest fires. These are some of the natural things. Now, along with these natural causes, obviously, we can also think about the human factors which are responsible for, which play their some kind of role in these disasters. Okay, so for example, when we are talking about cloudburst, so humans will not be having much impact, direct impact on the cloudburst. Yes, by the way of climate change we can link it, but similarly when we are talking about the earthquakes, so obviously humans are not leading to the major earthquakes in Himalayas. But yes, when we talk about the humans impact on the mining in the Himalayas, which again is relatively less, so that is why the human induced factors are mainly in those areas where you are having mining. In Himalayas, you are not having much mining. Okay, so that is why in Himalayas, human-induced earthquakes are relatively less. But how does it come? Because we know that in Himalayas, you are having a lot of reservoirs. Okay, and not just reservoirs. I want to club this as an example in the point. The major point is what? Infrastructural load. So the amount of infrastructure which we are creating, be it reservoirs, be it roads, be it railways, be it tunnels, anything. So this basically destabilizes the rocks in the local areas and can lead to the failure of the rocks, can lead to the earthquakes, can lead to landslides, can lead to avalanches, can lead to glacial lake outburst floods, right? Similarly, we can talk about the rampant tourism also, which can lead to wildfires. We can talk about agricultural practices also. For example, jhum cultivation we have talked about. We can talk about the rapid urbanization also, right? And then obviously you also can come up with a lot of factors. So these are human related factors which basically intensify these natural factors. And now this point is very important. The tragedy, the heading is Himalayan tragedy. This tragedy further intensifies, and we will understand this when we will understand that these disasters are interlinked also. For example, let's imagine that there was an upstream area. In this particular area, you experienced cloudburst, right? In this area, you experience disaster number one, which is a cloudburst. This cloudburst will lead to what? It will lead to increase in the downward movement of water, which can lead to disaster number two, that is the floods in the river, right? If somehow that river water is entering into a lake, that is this, so it can lead to the breaching of the moraine walls, which can lead to what? Disaster number three, that is the glacial lake outburst flood. Now the downstream movement of water will further increase, can lead to what? Disaster number four, that is landslides. Are you getting it? So this is basically what? One disaster leading to second, leading to third, leading to fourth, and this is known as the cascading impact of disasters. Cascading impact, right? A domino effect is being created. That is why when we talk about the early warning systems, we talk about multi-hazard early warning system. We need to develop that early warning system which can give us the prior informations about not just one disaster. We have to develop early warning system in this area which can take into account all these disasters simultaneously. This is known as multi-hazard EWS. Are you getting it? So yes, this was the discussion from this particular topic, and this discussion basically sums up every topic. Whenever you will find some topic in newspaper related to not just avalanche, related to any particular disaster or overall Himalayan vulnerability, we have adequate n number of recent examples also. We are aware about the Joshimath crisis. We are aware about the GLOF that happened in Sikkim in the Lonak Valley. We are aware about the recent forest fires which have happened in this Uttarakhand. And yes, one thing I forgot, that this particular region, Ladakh region, was in news because of one more disaster, which was basically the cold waves. Right? So Himalayas are also prone to cold waves. Right? We know that in the Jammu Kashmir region, we have Chillai Kala, the 40 days extreme cold waves are there. Chillai Kala, it is known locally. Okay, so this is the thing, that we have analyzed the Himalayas in terms of environmental as well as the climate or the weather related disasters, right? Now let's move towards the next topic. Yeah. Next topic is from climatology. The topic is in news because recently the WMO has said that there will be a weaker La Nina in the equatorial Pacific. So in this regard, we should understand that what do we mean by La Nina. Okay. So here again, if we draw the rough map, let's say this is African region, here you have Indian region, and this is Southeast Asian region, right? Small islands. So here you have Australia, and here I'm just roughly I'm drawing the South American region, Central America, right? This is Californian region, and then this is Alaskan region. This is somewhat like this. Here you have the Siberian region. Here you are having the Bering Strait. Okay, so this we all know is Pacific. This we all know is Indian Ocean. If we have to mark rough equator, so equator is roughly passing through this Congo, then Southeast Asian region, and this Brazil Amazonian forest. So this is an equatorial line. We are aware about the wind patterns in this area in normal situation. What happens in normal situation? We know that in this particular area, because if this is an equator, so that basically we are talking about the tropical latitudes, Tropic of Cancer and Capricorn. So between in this tropical region, between these tropics, you are having which type of permanent winds? You are having trade winds, which are northeasterly winds. That means what? The winds are moving in this direction, northeasterly trades, and here you are having the winds in this direction. So these are northeasterly trades, these are southeasterly trades. Pacific Ocean is the warmest ocean. Okay, so be very clear. You might find some sources which write Indian Ocean is the warmest ocean. Pacific Ocean is the warmest ocean. Indian Ocean is the most warming ocean, fastest warming ocean. So because of the climate change, Indian Ocean is warming up faster than the other two main oceans. But when we talk about the general, the Pacific Ocean is the warmest ocean. There is a reason also, because Pacific Ocean has such a large surface area which is exposed to the solar insolation for last millions of years since when this ocean has been formed. So because this large surface area is exposed, so whenever we are having large surface area exposed to sun, so there eventually initially it will be difficult to warm it, but once it has got warmed, so obviously larger area will invite larger amount of solar insolation and hence will be warmer compared to that amount of water which is having a short surface area. This you can understand by the common examples also. If you have to heat a water, so what do you think? Supplying same amount of insulation will heat the water having larger surface area or a smaller surface area? Okay, because if you are having smaller surface area, lot of heats will be wasted. We have to take sun as a source of heat, not a laser light. So a lot of heat will be wasted. But when you are having a large surface area like Pacific, so a lot of heat which is coming to the earth is being absorbed by this large surface area of Pacific Ocean, making it the warmest ocean. Fine. If we agree to this fact, if this is, so basically this is a warm water in tropical area, warmest ocean in tropical area, you are having a warm water, you are having a winds in this particular direction. So can I say that in this Pacific area, all the warm water of this Pacific in this tropical area is moving along with the wind from this point to this point, that is from Eastern Pacific to the Western Pacific? So can I say that in the Western Pacific, the warm water is getting collected? So here you are having what? Warm water, right? On the contrary, in the Central and Eastern Pacific, you are having what? Cold water. Because here you are having offshore winds, all the warm water is driven away from this to this. Here now the warm water is collected, here you are having cold water. There are other reasons also. You can think about the cold current also, which is on the western part of the South America, and because there is an upwelling cold current, so it is also bringing a cold water, making this area further cold. So in normal times we understand that the Western Pacific is warmer, has to be warmer, Eastern Pacific has to be colder. If this is true, then what will happen? If this is warm, so that means air, water is warm, air is also warm. Warm air, we all know it will rise, so it will go up. If it is going up, that means here you are having a low pressure condition. Here you are having cold conditions, so that means relatively high pressure condition is there. If it is a high pressure conditions, then the winds has to descend. The wind is descending also. So in this part the wind is rising, in this part the wind is descending. So that means, and in this part the wind is moving like this. So obviously in the upper atmosphere wind is moving like this. So this is one cycle in the normal times which has to be there, right? So this is a normal scenario. Here, if we are saying that the wind is rising, so can I say that in this particular area, because low pressure is there, the wind is rising, convection is there, so I will be having a lot of cloud formation also, and this cloud will lead to the precipitation in this area. So this area will be wet and this area will be dry. This will be atmospheric stable condition. There will be dryness, semi-arid area conditions. Here you are having precipitation, so that means wet condition is there and atmospheric instability is there. Fine. So this is a normal scenario. What happens in La Nina? during La Nina, these trade winds basically intensify. These trade winds intensify. When these trade winds are intensifying, that means the speed of these trade winds are increasing, which means now this warm water will be moving towards Western Pacific more relatively faster. So when this is moving faster, that means warmer conditions are now getting formed over here. That means intense low pressure is created. So in simple language, I can say, if we have understood this normal scenario, what is happening, La Nina is nothing but just the intensified normal conditions, right? Intensified normal conditions. In normal conditions, the Western Pacific was having rainfall. During La Nina, Western Pacific will be having more rainfall. In normal conditions, the Eastern Pacific was having dry climate. During La Nina, the Eastern Pacific will be having drier climate. So La Nina is just the intensified normal condition. Okay. During normal times, India gets rainfall. India gets rainfall during normal times. So if it is a La Nina period, so this rainfall further will increase because it is just intensifying the normal conditions. So during La Nina, that is why we say that generally we will experience above normal rainfall in India. True. What will be El Nino? In El Nino, exactly opposite will happen. This will become high pressure and this will become low pressure. So that is why no rainfall in India, then there will be droughts. That will happen in El Nino. But here we are talking about phenomena of La Nina. That is why, coming back to this headline, which is saying that it will be a short-lived. So now we have to see that how this short-lived La Nina is going to impact the coming monsoon in India. Okay. So that is why this topic is mainly the part of General Studies Mains Paper 1, because there you have the important geophysical phenomena where there are climatological phenomena also, right? So this was the topic. We have discussed the concept of La Nina. Moving towards the next topic. This topic is mainly from the prelims section and the topic reads about the Wallace line. Now, many of you must have read about it also. Very small topic. We just need to understand that what is basically a Wallace line. So it is an imaginary line. So there was a scientist who began, we'll read about it later, but first, there was a scientist who started to analyze the species variations across different areas in the world. And when he came across the Southeast Asian portion and the Australian portion, in the previous map of La Nina, here we have seen this is the Southeast Asian region, here you are having Australia. The distance between the Southeast Asia, the last point of the Southeast Asian islands, and the last point of this Australian biogeographic zone, the distance between these 2 points is very less, around 30-40 kilometers. Not about the continents, we are talking about biogeographic zones. So he observed that within this very small distance, what is that factor because of which there is a dramatic difference in the biodiversity? Okay. For example, see this. Yeah. Here you can see. So this is Southeast Asian region. You are having Sumatran Islands, you are having Java Islands, you are having Borneo Islands. Between Borneo and Sulawesi Island, this is an imaginary line, which is basically a Wallace line. Okay. So you are saying this line. So see the difference between this Borneo Island and Sulawesi Island. It is very less. Still, now this portion comes under the Australian biogeographic zone. This portion comes under the Eurasian biogeographic zone, right? Within this small distance, he observed that in this section, that is towards the Asian part, you are having the species like tigers, you are having orangutans, for example. As soon as you cross this line and you move towards the east of this line, you are having what? You are having kangaroos and such type of species. You are having marsupials, you are having koalas, right? You won't find marsupials in this portion. You won't find tigers in this portion, right? But the distance is very less. So what is the reason? So first, this imaginary line is known as Wallace line, which is in this particular area and which divides the species, which divides basically two biogeographic zones, the Eurasian biogeographic zone and the Australian biogeographic zone, right? If we have to see over here the facts, so Wallace line refers to a biogeographic boundary line that separates the Asian animals from the Australian ones. Okay, it was discovered by the scientists in 19th century. Not very important from UPSC's perspective. See, the distance is just around 35 kilometers. So just in 35 kilometers, you are having huge variations in the biodiversity in the species of it. Okay, what explains this? So there are three reasons which explains this. Okay, first is the continental drift and plate tectonics. Both of these areas, that is the Eurasian part and the Australian part, that is why you are having different plates also. So because both of these areas have drifted separately, different plates are there, they drifted separately, and hence the evolution of the species which took place in both these areas obviously will be different. So that is separate drifting. Second important point is there are very deep trenches in this narrow section. In this narrow section, there are very deep trenches. So historically, when the species, land species, used to migrate, for example, kangaroo or let's say tigers, when they wanted to migrate, they cannot migrate because here you are having a deep trenches, right? So this geological feature has affected their migration because they have evolved in the historical ages. So that is how the information might have been spreaded to the newer generations, that you don't have to move to these particular areas. Okay, so that is how naturally they adapted to this hostile situation, and then now they never cross this particular line. So because there are deep trenches, formation of trenches again is related to what? Is related to the plate tectonics. The second thing is the Lombok Strait barrier. So when we talk about the Lombok Strait barrier, so in that strait, in this same area, in this strait, the narrow passage of water body, in this strait, you are having a trench. That is true. Even during the ice ages, that is going back to in the geological time scale, even during ice ages, when the sea level fell down very drastically, right? Even in that area, because the trenches were deeper, these trenches were submerged. During the ice ages also, these trenches were submerged, which prevented the species from crossing between two regions. Because in different areas of the world, we have seen that during the ice ages, when there was no water, the migratory pattern of the species has changed. But we didn't see that in this particular area. Why? Because even during ice ages also, these trenches were filled with water, which prevented their movement. Then we have isolation and evolutionary differences. Both of these areas are having different types of climatic conditions, which has led to specific adaptation mechanisms in different species. For example, in Asian species, you will be seeing the placenta mammals. So these are the placental mammals like tigers, elephants, monkeys. As you move towards the Australia, in Australia you find marsupials like kangaroos and koalas. So both these different types of species have tried to adapt themselves as per the different climatic conditions also which are prevailing in these areas. Okay, so this explains the dramatic shift in biodiversity as soon as you cross that just narrow 35-kilometer of zone, and that imaginary line is a Wallace line. Next topic is in relation to the Gangetic dolphins, because recently it has come in the newspaper that the first estimate of the Gangetic dolphins have come out, and they have presented us the data. So obviously this species is important. We know that in every year in prelims paper you will see such type of species and questions associated with it. More importantly, because we are talking about Gangetic dolphins, which is national aquatic animals, so obviously the species is important, and this data is also this report is also important. Okay, so first let us look at some of the key facts related to the Ganges river dolphin. Okay, so this is the shape of dolphin. Here you can see it. When we have to talk about the primary range of these dolphins, so they are freshwater dolphins. That is why they are in the river systems like Ganga. So they are not just found in Ganga river systems, they are also found in Brahmaputra along with Ganga. Then they are also found in Karnafuli, Sangu river basins and their tributaries in India, Nepal and Bangladesh. So basically, India, Nepal, Bangladesh, Ganga river system, Brahmaputra river systems, in the freshwater rivers, you will have these dolphins, right? They are blind. They cannot see, right? So they are blind in nature. So if they cannot see, then how do they move? How do they locate their prey? How do they locate their food? How do they eat? That is done on the basis of the sound signals which they make, right? That is known as echolocation. We'll come to it, but first we need to understand that they have very poor eyesight. They are almost blind. Okay, they cannot see. So this feature, this is the mouth of the dolphin, and if you can see that this nose of dolphin and this mouth of dolphin, sorry, this mouth of dolphin is closed, but still you can see the teeth of these dolphin. So this is a specific feature of Gangetic dolphins. It says that it has a very long pointed beak with sharp curving teeth visible even when the beak is closed, especially in the younger animals. So it is closed, but still you can see these teeth. What do they eat? They are carnivores, so they eat fish, shrimp, they possibly eat turtles as well as some birds, right? They use sound waves to move, to navigate. This is known as echolocation. Just a minute. Yeah. So in this picture, you can see that what we mean by echolocation. So this is a dolphin. It basically sends these sound signals. Those sound signals hit the species and then they come back on the basis of this, and then these dolphins obviously receives these signals which are returned, and on the basis of this they are able to identify that in which area there are species which they can hunt, which they can feed upon, or which areas can facilitate their movement. Okay, so this is that they send this sound and then they receive back this sound. This is known as echolocation. They observe the echo of the sound, right? So because they are blind, so that is why they have developed such a type of technique. Lifespan is around 18 to 22 years. If we are talking about the habitat, so they are mainly in the slow flowing freshwater rivers, mostly in the plains, often sited at the river confluences, right? Other important facts are females are larger than the males. This is very important one given the nature of the recent questions which are asked in prelims. Then they give birth once every 2 to 3 years. When we have to talk about the social structure of these dolphins, so they are mostly seen alone or in pairs. So that means they are not very social animal, right? So they love their loneliness. And again, we know that what are the major threats associated with it and what are the important conservation things which we have done to protect our river dolphins. These are just the factual information. We know this. However, from the examination perspective, from the prelims examination perspective, this is the information which is more relevant, right? Coming to the data, yeah, the important key facts, some of the important key facts from the Gangetic dolphins as well as from the recent report in which regard we are discussing this particular topic. It says that the Gangetic dolphins are found in Ganga, Brahmaputra as well as the Beas river. Now Beas river is a river of Indus system, so that means you have Gangetic dolphins in the Indus river system also, so you don't have to exclude it. When it comes to dolphins in India, India is having Gangetic dolphins and Indus dolphin, which are different. They are related but different varieties, right? So that is why. So this is the thing. The first ever survey, it has been conducted by Wildlife Institute of India and state forest departments. It was conducted under the project Dolphin, launched in 2020. The next survey will likely take place after 4 years. The highest number of Gangetic dolphins are found in the state of Uttar Pradesh. The highest concentration is found in Chambal River. Then here are some of the data that this is the first estimate. Then Brahmaputra tributary is this much amount, Beas river this much amount, Ganga tributary this much amount, and Ganga mainstream. You can see the largest presence in the Ganga mainstream, right? Fine. So this was some of the facts. Okay, let's move to the Okay, two important facts is also there, that these Gangetic dolphins are basically the umbrella species. Umbrella species means, so they are like umbrella. If you are under umbrella, you are protected from the rainfall. Similarly, if some species is an umbrella species, that means if that species is protected, if your umbrella is safe, you are safe. That means if the umbrella species are protected, all the species which are lying under that umbrella species in the food chain, food web, all those species are protected. That means this is a guarantee. If these dolphins are protected, that means the aquatic system is performing good. That is why they are also the bio indicators of the healthy rivers. If there are dolphins, that means river is healthy, right? This we have discussed, that India is home to two species. One is Indus River and one is Gangetic dolphin, right? Next, moving to the next point, that is Madhav National Park, which has come into the news because it will now be recognized as a tiger reserve also. 58th tiger reserve of India is Madhav National Park. So in this regard, obviously we should know the important key facts related to this particular protected area. Again, an important key theme when it comes to UPSC prelims examination, right? Yeah. So first of all, with the help of this map, we will see this is a Madhav National Park protected area. This is the area which we are talking about. It is lying in the state of Madhya Pradesh, and that too towards the northern portion of the MP. Here you are having Madhav. This will be the ninth tiger reserve of the Madhya Pradesh. Before that, there are 8 tiger reserves. Which are those 8 tiger reserves? All these reserves are also very important. So there are 8 tiger reserves. First is Kanha Tiger Reserve. So in this map, here you are having Kanha Tiger Reserve. Then you have Bandhavgarh, Pench, Panna, Satpura. So here you have Pench, here you have Satpura, here you have Bandhavgarh, here you have Panna. Then you have Sanjay, Ratapani, Noradehi. This is Ratapani, this is Noradevi and Noradehi, and this is Sanjay Tiger Reserve. Okay, so in totality, you have now 9 tiger reserves in MP. But we will see that this Madhav National Park is towards the northern section. Rest of other of the major tiger reserves in the MP are either south or southeast section of MP. This one is the northern part. Okay, yeah. So this is northern part, and then the district is Shivpuri district, and here we also know that these are the central highland areas when it comes to the India's physiography, and the northern section of the Vindhyan Hills. So that is by central highlands and the upper Vindhyan Hills. In this Madhav National Park, you have two important lakes. One is Sathya Sagar, one is Madhav Sagar, the same name. Marsh crocodiles are found in this particular area, Madhav National Park. You have the crocodiles also. There is one important dam, that is Madhikera Dam. This we have discussed. The area is blessed with which type of flora you will get? You will get dry deciduous forests and then the thorn forests. Why? Because we know that this particular section of India, so here you are having Aravallis, here in south you are having Western Ghats, here towards the north you are having Himalayas, but this section of India is having what? It is having semi-arid type of climate. Also, it is having what? Bad land topography. This particular section, when we say it's a section of Bundelkhand region, also the northern MP and the southern Uttar Pradesh section, this section is a bad land topography having semi-arid climate. So that is why you will be having dry deciduous because the rainfall is less, and in some positions you can have the thorn forest also. This area, this Madhav National Park, is a home to a lot of species like tigers, leopards, nilgai, chinkara, chausingha, and various kinds of other species of deer. Right? So these are the important key facts related to the Madhav National Park, which now is also a tiger reserve. The last topic is from the again from the prelim section. Recent development in the climate change negotiations is that US has exited. So it keeps on exiting and then coming back to different types of international treaties, but fine. So now US has exited from the climate climate change damage fund. So you must have heard about a key word, that is loss and damage fund. Okay, so that loss and damage fund is the same fund which we are talking about, and US has exited. So when the loss and damage fund was formed in the COP summits in 27 and 28, COP27 Sharm el Sheikh, and then COP28, in these, on those times, we acknowledged the role of the countries in order to establish the loss and damage fund. Okay, so we hailed it because it was a necessity to support the least developing countries as well as particularly vulnerable countries, small island states. It was a necessity. But now we are seeing that US has exited it. So that's why I keep on saying that when some protocol is signed, we have to wait and watch to understand its performance. Just establishing one fund or some protocol or signing or ratifying it will not make much difference. Laws are formed in the parliaments, but how these are implemented on the ground, that is the main thing. Anyways, we have to see that what is the background. Again, just revising the facts. I know that we have done this many times, but let's revise these things. So the background is this, that it was established under COP27 in Sharm el Sheikh, Egypt, and it was operationalized in COP28. The basic theme of the basic crux of loss and damage fund is, so when the UNFCCC, United Nations Framework on Convention to Climate Change, so since its beginning, when we talk about the funds or the finance in the climate, so we talk about the obviously adaptation funds, mitigation funds, and we have also talked about the loss and damage funds. Highest focus nowadays is being given to the adaptation funds. Less focus is given on the mitigation, which is a bad scenario. We should give adequate focus to mitigation also. But least focus was given on the loss and damage. Now, how loss and damage as a concept is different from adaptation and mitigation? See, adaptation fund is the fund or a support which should be provided by developed world to the developing world to adapt to the climate change. Adaptation means that climate change is a reality. The floods will come, the weather extremities will come. You have to adapt to it. How you can adapt to floods? You can adapt, there might be rehabilitation, that you rehabilitate this section of population from one area to point B, and there you establish the homes. Obviously you require money for it, so the fund can be used. Or you can go for strengthening of the embankments, that if the flood comes, so there is no spillover, or you can reduce the impact of the floods. That is adaptation. You have acknowledged that there will be disasters, there is a climate change, now you have to adapt, right? Mitigation is a preventive mechanism, that you take such steps that you do not allow the climate change to happen. Okay, so that is mitigation. But in both of these scenarios, we are talking about the preventive measures as well as the reactive measures that developed world is supporting the developing world. But the question is, what about the impacts of the climate change which have already taken place in the developing countries because of the actions of the developed world? What about the compensation given to those developing countries which are actually facing the brunt of the climate change? What about the small island states where the coastal areas have been submerged completely? Okay, so that does not come under adaptation or mitigation because they have already faced the loss and damage. So to compensate them, we have the loss and damage fund. So that is why it is a different concept from adaptation or mitigation based funds, right? This is loss and damage. Basically, it was an insurance or a compensation being given by the developed world because of their energy intensive actions which they have taken in the past since the beginning of industrial revolution, and those actions have detrimentally impacted the other smaller countries. In order to support, in order to compensate for the loss which have already occurred, we came up with this idea of loss and damage fund, right? So it established under COP27, got operationalized in COP28. The focus was on developing and the vulnerable nations, particularly small island states as well as the least developing countries. What is the objective or the purpose of this climate damage fund? It is known as now climate damage fund, the fund for responding to loss and damage, right? So obviously addressing the losses and damages, support the recovery and rehabilitation, aid in non-economic losses, also important, economic as well as non-economic losses. For example, the cultural losses are also taken care in the loss and damage part. and then enhancing the climate resilience. These are the major objectives of it, right? Structure and governance, the fund operates as an entity under the financial mechanism of UNFCCC and Paris Agreement, right? We discussed that when the UNFCCC was formed, so since its beginning, we are talking about loss and damage, but not much focus was given to it. The fund is expected to work in coordination with the other important funds, like we know Green Climate Fund, Global Environment Facility, as well as adaptation, GCF and GEF. So GCF and GEF will work in close coordination with this fund also, it is expected. Funding sources and contributions, again, there are no clear-cut guidelines, but we expect that all the types of funding mechanism will be arranged. That is the funding from the government also, developed world to developing world. Private funding will also be there. So that is why the developed countries are there. Multilateral institutions are also taken, and then private sector contribution, and then we can also come up with the innovative financing mechanisms. How will it move? Again, we have to just wait and watch, then only we can discuss about it. But yeah, all sorts of fundings, we expect that it will be there in this particular fund, right? So this is the thing. So this was all for today. Now coming to the practice questions, very simple questions from the discussions which we have done. So just give yourself a time, or you can pause the screen, take the screenshot or whatever, and then just try to attempt these questions. Okay, so the first question is in relation to the fund which we have just discussed. The second question is related to the La Nina. Then we have Madhav National Park question, and then we have the question on the Wallace line, mainly from the prelims section. Okay, the question, the types which we can expect in the prelims examination. So try to attempt it, right? And the correct answers for these questions are this. Okay. Now, because these are very simple questions, just read the questions carefully. In this question, they are not mandated. We just saw that expected, right? Then here also in question number 1, when we are saying La Nina is characterized by the warming of the sea surface temperature in the Central and Eastern Pacific. So during La Nina Pacific, the warmer water was getting collected over the Western Pacific, not the Eastern Pacific, right? When we talk about the Wallace line, so here its third statement is it runs between the islands of Sumatra and Borneo. No, which were the names of the islands which we discussed? It was not Sumatra and Borneo. Write down in the comments. Let's see that whether you remember it or not. Okay. And then from the Madhav National Park, here the first statement says that it is located in the state of Rajasthan. No, very easy questions, right? So yeah, that's all from my side for today. This was the discussion. I hope you have enjoyed it. If yes, just let us know by liking, by commenting, by sharing it with your friends. Thank you and all the very best.